coming in today. Hello. Alright, hello there too. So today we're going to be going over tools, how to, all the supplies, everything, all the basics on tools and supplies you need to be ready for robotics and to be ready to build stuff. These are essential things to know and essential tidbits of information to your ease and success working in the makerspace. So I think we should get into it. So I guess I'll go through these slideshows, and then if we have time after, we'll do some demos and we'll have some practice using some of the machines we have here in our makerspace. So let's get into it. So first off, we have our makerspace. So I'm gonna stand over. So this right here, this room is the makerspace. It's where we build. Over there is our tool cart. That houses all the tools and the hand tools mostly, which we use to build the robot. As you know, behind the next door over is the supply room. It holds all our supplies and various things we need to build a robot. This includes all our fasteners, our straps, and our tubes of metal, everything. And then next door is the Maker Studio. That one, the Maker Studio, we don't do as much R&D in. We generally like to keep that as a place of brainstorm. So, I guess it's just good to go over where we get our supplies. So you go to Vex Robotics Pro for all our gears, sprockets, chains, axles, stuff like that. Those basic mechanical components for our robot. AndyMark is another very, very useful store. It has I guess more electronics and more niche stuff. Same with West Coast Products, and we also go to Home Depot sometimes for screws. Alright, so I think in relation to tools, we should know what's ours and what's not ours. So if you go over to the cart, I can go over here to the cart. I guess so as you see, all our stuff is labeled with our team number 5735, and it's located on the tool cart. If it doesn't have our number nor is located on the tool cart, it belongs to the school. This doesn't mean we can't use it. We can borrow it. We just have to put it back. We don't want the school to accuse us of stealing this. It's not good. All right. Next slide. So going on into tools. First up, we have the screwdriver / impact driver. So screwdriver, I think all you guys know that. You use it to screw in screws. And the impact driver is basically an electric version of a screwdriver, which is different from a drill / drill press. So as opposed to screwing in and driving in the hole, a hand drill, and a drill press make the hole, they bore the hole. And 3/16 is a golden number here in robotics. It's the hole that we use for all our screws. It's the whole diameter we use for the majority of our machine screws. And it's the drill bit that is most commonly used when using a drill and drill press. So 3/16. That's the hole. And if you look at our robot, you'll see that there's a lot of holes on our robot. That's because holes are vital to mounting and attaching and basically putting together the robot. You need holes to put in the bearing, to attach the fastener. So yeah, drill and making holes and drill press is very vital. So yeah, going on, we have different drill bits. So as you see over here, they're varying sizes. Again, 3/16. That's why there's two of them, because it's very important. It's a very important hole diameter for robotics. And another drill bit I want to bring to your attention is this bit, which is called the step-up bit. It's it's a little unorthodox in that it's a cone shape, and that's because of its usage, which is to make a hole wider. So if I can get a marker here. So say this is a block of wood or metal I want to drill in, and I want to drill in a hole across here. This is a side profile. So I want to put in my screw, right? Sometimes this orientation of a screw is not ideal because it's susceptible to a lot of stress and it can easily be damaged. One thing with screws is you want the shortest size possible. So we'd much prefer to have the screw, this is the head by the way, and that's the nut, to be in a more tightly fastened orientation. But as you can see, in order to do that, you have to screw this in here somehow. But we have all this material blocking us. So use the step-up bit to make this hole larger so we can use our screwdriver to screw in the hole. Does that make sense? Yeah, okay. So that's the main use of a step-up bit, and that is very different, and each level is a different, correlates to a different diameter. All right, so next up, along with screwdrivers, we have wrenches. So wrenches are used for tightening hex nuts, which are the nuts part of the nuts and bolts. So yeah, wrenches, they go in tandem with screwdrivers. Whenever you screw something in, you always want to hold it with a nut and a wrench on the other side so you can tighten it. There's many different types of sizes of wrenches, of course, but 3/8 is probably the most commonly one used in robotics because it correlates with the nut size, the hex nut size used for the screws we use. So 3/8, another golden number. Over here, you can see this wrench is a little different. It has like a little bit of a different coloring. It's black. That's a ratchet, and it's basically just like a wrench, except you can adjust the system so it only tightens one way. It's really useful for if you're working with a wrench in a tight space. But yeah, wrenches and screws used to fasten nuts and bolts. It's that's how it works. So again, what do we use? So what are we tightening? So we're tightening fasteners. Specifically, we're tightening nuts and bolts. And even more specific, we're tightening machine screws. So there's lots of different types of screws for various purposes and stuff. But we use machine screws that look like this. This one right here, with the Phillips head to screw in. So that's the robotic screw. You can see there's many different types of screws with different types of heads. This one right here is counterbored, which means that its head is like caved in. It's really good for if you really want to jam your screw into the material and have a really tight fit. It's typically used for it's used in much bigger screws for a lot tighter fit. This right here, it has a different head. It's a hex head. So instead of screwing it in, you wrench it in. It's like you attach. It's like a nut mounted onto the end of a screw. You still put a nut here, but yeah, use a wrench for that. And then down here, sometimes when we're prototyping, we use wood. And so this right here is a wood screw. A notable difference is that its threads poke out more and its tip is pointed. So that makes it easier to go into wood, which is yeah, helpful for that. All right, so another big thing is screw sizing. All right, I know it's kind of boring talking about screws, but like it's kind of important. So we have a lot of screws. This box right here is full of screws, and it's full of one type of screw, which is the 1032 screw. So 1032, what does it stand for? I don't really know. Like it's kind of complicated. You can look at this diagram. It has like some. So we use imperial here, right, in the U.S. So unlike the metric system, which has like M5, M6, it's like makes kind of sense. This has like 440, 832, 1024, like weird measurement system. Has something to do with the amount of threads per quarter of an inch on the screw. But all you need to know is that for robotics and for all our like components, the viable screw, or the screw that works, is 1032, which correlates with the 3/16 holes. Sometimes we use 1024, but that's sometimes. You'll know. You can tell the difference because 1024's the threading is a little bit wider, so you'll see like it's a little bit spaced out. Yeah. Going on about screws, you can expect them to be like anywhere from 1/4 of an inch to like 3 inches to 3.5 inches. One thing to know is that if you're like using a screw, if you're like screwing something and you need something more than like 3.5, you're probably doing something wrong. Generally, you don't need to use with like screws like a 1024. You don't need to use. It's not meant to be used for anything longer than like 4 inches. So generally, if you need to use a screw like that, your design might be unstable or unstable / not resistant and not very sturdy. If there are times when you like have to like put something together and it's like 4 inches apart, but what you do, so say I want to put together like, say there's like a block here and it's 4 inches wide, and there's another like a thin slice here. So this is like a block of metal. These are two thin strips of like PC, and I want to put them together. Instead of doing one screw through the whole thing, I'd put 2 screws like this, one going either way. Does that make sense? 2 shorter screws into the material. And again, I bore out a hole here and nut it through on that side. Does that make sense? I say this because like I spent a lot of time looking for like screws, like weird screws, because I couldn't, because I don't know, I needed long screws and they don't really exist. So. Good thing to know. Yeah, that's screw sizing, kind of boring, but then there's hex nuts. So yeah, along with screws, you have nuts. There's 2 main types of nuts, hex nuts. So you got normal hex nuts and you got nylox. The main difference is that nylox have this thin strip of nylon in them, so that makes them a little bit more permanent, a little bit more tighter, and a better fit. Generally, when you're prototyping, you use hex nuts because they're easier to disassemble, and like so you can easily reiterate, change your design, take things apart. But on the final product, we use hex nuts, and we might even pour this stuff called Loctite, which is like this glue you use to keep screw fasteners together, and that gives us the best fit possible for a robot. So yeah, those are hex nuts. And in terms of sizing, honestly, you just like test. You like take your screw in your nut. If it works, it works. If it fits, it fits. All right, so here's another type of connection. I think it's our last type of connection we really use. It's rivets and riveters and rivets. So if you ever seen like a plane or the hull of a boat, you'll see like those metal like circles on the side, with the sheets. I don't know if you like seen that. Yeah. So those are all rivets, and particularly on those like boats and planes, they use like really big rivets. Here we use like small, like 3/4 inch rivets. Yeah, we use them for metal to metal connections. You have to use a riveter to rivet to attach a rivet. So you place a rivet. Here, I can go grab it. Ugh. I don't have any rivets on me, but here's the riveter. So you stick the you stick this part inside the rivet, and then you have to drill a hole, another 3/16 hole, and then using your riveter, you just squish and the rivet rivets. I guess that's the best way to say it. Yeah, it's pretty cool. The way it works is that like when you squish the way I like was told it works is when you like squish the thing down, the pressure like expands and it like creates a good fit. So Oh yeah, and again, if I didn't mention before, they're kind of hard to undo, so we don't use them that often. All right, so these are another great tool. So I talked about all these measurements, but like, yeah, sometimes you might not know what like the size of something is. So then you use calipers. These are used to measure screws, nuts, spacers, and like other small hardware. So the way these work is that we have electronic calipers, but there's these two sort of teeth slash prongs, and you use a slider to slide the to vary the distance between the prongs, and you stick your desired this desired subject to be measured. Say if I want to measure the width of the screw, I stick it in between, and then I collapse the calipers together, and the calipers will output output the measurement of the diameter. So yeah, they're very useful. They're like minute rulers, or like rulers meant to be used for like small scale. You know, because it's hard to like hold up a ruler and hold it steady and measure stuff like that. One thing to point out is that like this one can measure outer diameter. These two prongs, you see, they go this way. So if you want to measure the inside of something like the inside of a bearing, the inner diameter, you can use these two, and these two will tell you the measurement here will read out the inner diameter. One thing to know is here we don't have like our calipers are all are electronic, so you don't really need to worry about reading all this. So yeah, that's calipers. Very useful. Very useful tool. Spacers. So another little piece of hardware. Come in variety of lengths and variety of sizes. Like they don't look like much, but they're very useful. You don't realize how useful spacers are. They're good for like, we use them a lot in robotics to mount things together. You need spacers in between things so things don't crash together. It's hard to imagine, but they're very useful. That's why we have like a whole bin of them. We 3D print all our spacers, so that's why a big use of our 3D printer in our supply closet is for spacers. They come in all different lengths and different diameters for screws, and yeah, they're very helpful. Next slide. Next we got bearings. Again, saying more hardware, but it's important. So bearings, these are like pieces you put. These are like pieces that attach axles. So if you look in here, this inner part can spin freely while the outer part stays still. So you can put this in a hole. Like if you cut out a 1.125 inch hole, which is 1 1/8 hole, into a piece of metal, and you put in a bearing, you can stick an axle through, and you basically got yourself like, put a couple of those together, you got yourself like a car. You can put like, yeah, you got a little bit of an oversimplification, but you get what I mean, I hope. You put an axle in there, it spins freely while attached to the chassis, and you can put a wheel on, you can put gears, sprockets, whatever. Yeah, those are what bearings are for. We can pull them out after the slides if you want to see a better, more specific demonstration. So then there's hex axles. So those are the axles we use. They're hexagonal. As opposed to circular, hexagonal axles are more sturdy and tough. Circular ones are harder to work with, and circular ones are prone to, you'd think like circles are easy, but they're harder because they're very fragile, I guess is the way to put it, from what I know and experience. But yeah, they turn stuff, so you attach it to a bearing, You can put like a pulley system on there. So like if I have an axle here, I can have a pulley here and a pulley here, chain. You see that? Got a system, mechanical system. So yeah, axles, pretty important. Oh, one thing I know I omitted from this slide are bearings, or sorry, not bearings. We'll get back to that. All right, pulleys. What is it called? Well, we'll get back to it after the slideshow. So next we got pulleys. So they attach to axles. They're paired with I don't know what that says, but the common teeth circumferences are like 16 teeth, 24 teeth, 32 teeth. So what I'm saying is that like the distance between each of these ledges, is the teeth, and they pair with certain belts that match the pitch length, which is the distance between each teeth. And so yeah, belts and pulleys pair. Oh, that's what I said. They pair with belts. So yeah, belts and pulleys pair, and they create system, mechanical systems. Like for example, last year we used belts and pulleys as our shooter. So the belts, they're made of like the plastic rubber material. So that's very good for transporting objects like a belt. So if you squeeze that into it, if you sort of squish a ball between two belts, you get basically yourself a flywheel, and you can shoot out balls that way. So it's pretty cool. Yeah, pulleys. All right. Next up, we got belts. So yeah, belts are with pulleys. You can put them together to create stuff. One thing to note is that belts are finite, so they're already in loops. Like the rubber is already sealed, so they can only go. You can only put them in certain orientations. / you can only mount them at certain measurements. So like if two pulleys are too close and you have a big belt, it's not going to work. It's too big. It's just going to flop. You need the right belt for the right distance and the right pulleys. So to determine the size of a belt, you'll see, it's kind of hard to see here, but you can see like numbers, and not if you agree. Yeah, not if you can see numbers here. So you'll usually see something that says X, it'll say number, X, T, and then some gibberish. So the X is referring to the pitch of the teeth. So it's like the distance, this distance between here. That's what X is referring to. That's what the number before T is referring to. And then you'll see some gibberish, and then you'll see another number followed by millimeter, and that is the total circumference of the pulley. So with that said, if you divide the total by X, you get the number of teeth, which is vital for when you're designing. You want to know the number of teeth you're using, so you can, because it corresponds with the teeth on the pulley. So yeah, and X usually equals 5. So if you can't find X, just assume it's 5. Sometimes they'll just say like random gibberish and then like a number, like 10,060. Just assume 5. That's like amazing. So next we got sprockets and chains. Another really cool thing. Yeah, so same as pulleys, they come in a variety of teeth, sprockets, and you pair them with chains, so they go together. So everybody's seen like the chain on their bike, right? Like everybody's, yeah. So the cool thing about chains is that you can resize them, because you can take apart. You can use a chain breaker and break a chain and shorten its length or increase its length by adding more individual like chain pieces. So that's very useful. I guess the drawback is that they kind of lose tension easily, so you need to use a tensioner to maintain its viability. Apart from that, they're quite good. We use both belts and chains. They each have their own uses. don't count one out, or usually we'll figure out which one's better in the situation. Chain braking, chain breakers. That's this over here. The device is used to break and reconnect chains. Some of us, or Tyler, he's really good at chain breaking. It's like sometimes you just can't get the right size for a chain, so it gets really frustrating when you keep on breaking and re-breaking. Sometimes the whole thing falls apart, right? Amy has a lot of experience with chains. Yeah, they're pretty cool. Next after sprocket. All right, that's it. Anyways, wait, I think I had more. All right. So after that, I guess we can do the tour of the makerspace. All right, yeah. So first up, we got any questions actually, like any questions at all about anything, any like building questions. Yeah, Ford.
Do you use gears for power transmission a lot?
Gears. So we do have gears. We don't use them. That's the thing. We don't use them for transmission. So the reason is that gears, as opposed to belts and pulleys, they have to like kind of stay together. So if they get jostled or like slightly nudged, it kind of messes up the whole system, right? Or if like a teeth if the teeth of a gear gets messed up, the whole system kind of dies. So they're really fragile, and we tend to steer away from them. But we've used them. Like we use them in like some like direct motor transmission. But yeah, that's a good question. Any other questions about anything? Like any building, any like something you want to know about building in general, or like mechanics? No? All right. So with that being said, let's go turn our attention to the laser cutter. So it's really useful for getting out a quick design getting your design out and fabricated. For our early prototypes, again, we design it on Onshape, our creation platform, and we'll upload our design to the computer and we'll laser cut it. We never use for prototypes we always cut with wood. So if you look back there, there's a variety of cuts of woods. Those are the maker spaces, so we don't want to use too much. So we try and like be conservative with the amount of wood we use. But yeah,
Can they go look at the laser cutter?
Yeah, sure, get up and look at it. Yeah,
Here we're going to talk about safety